something a polynomial? This is resource page 1. Definition. So it is a function with real coefficients. Honestly, everything we've studied this year has been real, but there is such thing as an imaginary number. Real just means that you could find it on the number line. Imaginary means it's I and it's not on the number line. And it has to have whole exponents. A whole number is 0, 1, 2, 3, ... So whole means it's not a fraction, it's not negative. We know that anything to the 0 power is 1. So x to the 0 power is allowed because x to the 0 power is 1. So x to the first is linear, x squared. Characteristics and some examples. So characteristics, its graph will always be a smooth curve. So it has to have a smooth curve. It can't have jagged edges. It has to be continuous. Its domain will always be all real numbers. Right? You can plug any number you want into a linear function. You can plug any number you want into a quadratic function. Some examples. Y equals 2x plus 5. That's just a line. I know I said a smooth curve, but a line is also considered a smooth curve. There's no jagged edges on a line. So this is considered a smooth curve. This is considered a smooth curve. Something with jagged edges might be like the absolute value function, or something that's not continuous that we haven't really seen, but right, that is not continuous and has a jump. Uh-oh. I hope I brought my charger. Oh. Okay. Okay. So another example. What does the prefix poly mean to you? Anyone know what poly means? Usually people think of polynomial as more than one. Polygon has more than one side, right? Poly. It doesn't necessarily mean it has to have more than one term. So I want to write down an example, something that only has one term. That's considered a polynomial function, even though it just has x cubed. Something else that's a polynomial function. Y equals 7. That's a constant line, right? So y equals 7 is a constant function. Okay, so some non-examples. Y equals the square root of x. Can't have a square root. Y equals 1 over x. Can't have x in the denominator. Y equals x to the 1/2 power. These are the same, right? Square root of x and x to the 1/2 power, that's the same function. Y equals x to the negative first power. That's the same as 1 over x, right? X to the negative first. So see how I can't have fractions? New unit. So big ideas. If we could just not have talking, that would be great. So x to the 1/2, x to the negative first. So your first job on Friday on the quiz will be identifying, yes, this is a polynomial, but no, this is not a polynomial. So even though we might have studied it this year, it might not be a polynomial. Absolute value function, not a polynomial, right? It doesn't have a power of just x. Okay, degree. I think you know what the word degree is. What would be the degree of this function, do you think? 3. What is the degree of this function? What's the power of x? 1. I should write down one more example. about y equals x plus 3x squared plus 1. So why is this a polynomial? That's just a quadratic function. It's not written in standard form, but that's okay. It's still a polynomial function, even if it's not written in standard form. Hey. Oh, there's another one we should write down. About the square root of negative 4 times x. Oh, sorry, this is non-polynomial. The square root of negative 4 times x. Why is that a non-polynomial? What is the square root of negative 4? Undefined, right? It's not a real number. So anything that is not a real number goes over here in the non category. Nice of you to join us today. You were on page 1, sir. Sure, I thought you had. All right, so job number 1, what is a polynomial? Hey, Bryce, you want to snap a picture of that quick? Or you could just use Killian's probably, right? Okay, so next, here's what you have to be able to determine about a polynomial, the degree. The degree is the highest power of x. So in this function, the degree is 2. I don't care about this x. This x is higher. The degree is 2. So this is a quadratic. This actually has a degree of 0. There's no x's. The leading coefficient is the number in front of the highest powered term. So the reason they call it a leading coefficient is because it usually comes first. What do you think the leading coefficient is in this example, though? The 3. So in standard form, it would have come first. This is scrambled up, so I can just pick that the number would be 3 because it's next to the x squared. All right, so you've got 4 examples here. Like a quiz question for Friday. Identify if it is a polynomial function, yes or no. If it is, we need to write it in standard form, highest to lowest power. State the degree and leading coefficient. So let me give you a hint. There's only one out of these functions that fails as a polynomial. So let's figure out together which one of these is not a polynomial. There's only one of them that fails. Why is number 4 not a polynomial? So 1/2 in the exponent. So I want you to circle and say not because it has a fractional exponent. So all of the others are polynomials. It would really help if you guys just didn't talk right now. Even if you're not going to write anything down, try to listen to the new unit so we can be successful. It's only a 9-day unit. This could be your best one yet. All right, number 1. What might make you think this is not a polynomial? I don't really like the number pi right there, but is pi a real number? 3.14159, it just goes on forever. So it just said it had to be a real number. It's on the number line. So I can just write this in standard form. Let's see, 2x cubed would come first, then 2x squared and minus pi x. So there's standard form. What's the degree of the function? And what's the leading coefficient? So the degree is 3, right here, and the leading coefficient, what comes right in front of it, is the number 2. So I don't use an x in either answer. The degree is the number 3, and the leading coefficient is the number 2. See if you can put number 2 and number 3 in standard form. And what might make you think they're not a polynomial? I threw a couple f of x's. That just means y equals though. And I threw a square root of 3 down here, but the square root of 3 is 1.7. So this is just minus 1.7x. If the negative had been under the square root, that would have been a no-go. But square root of 3 is okay. 1/2 have it in the exponent. It is based on the power of the x. So this guy still gets to come first, even though it's negative. So this one would be f of x equals negative 3x 7 plus 2x. There's some of you who might really like this unit. There's a lot of Algebra 1 throwback. Adding together like terms, multiplying like terms. 10. This time. Okay. So what was my degree for this one? My degree would be 7. My leading coefficient should be -3. And then on this last one, it's already in standard form. I'm just going to circle that this is standard form. And what would be my degree and what would be my leading coefficient? My degree is 3, that's cubed. My leading coefficient is number 1/2. So those are two of the things that you need to be able to do this unit. Identify, is it a polynomial or not? Put it in standard form and state the degree and leading coefficient. Very similar to quadratics, right? We already know what standard form is in quadratics. So there's not a whole lot of new stuff. It's just reintroducing you to the vocabulary. Can I turn the page? Okay. Here is a lot of vocabulary that I don't want you to have to write down because you probably already know a lot of these words. There might just be one word that you don't know on here. If the degree is 0, it's called a constant function. The example I put on the front page was y equals 7. So that's, what kind of a line is that? Do you remember? Y equals 7. What does that look like when I graph it? Straight line at 7. So that's called a constant function because y is always 7. Give me an example of a linear function. 2x plus 79. Sure, that's a linear function, right? Y equals mx plus b. I could even have like y equals 3x with no y-intercept. The y-intercept would be 0, slope of 3. So that's a linear function, but that's a constant function. They're both lines. Quadratic function, we know that one. We've studied that this year. I can just write y equals like 4x squared. That would be quadratic. I think you know cubic. Y equals x cubed plus 2x squared plus 11. You do not add the numbers together and say this is x to the 5th, right? This is x cubed. Cubic, the biggest one. This is the one new word that you might not know, quartic. So that might be the one new vocabulary word on this whole page, but now you own all of them. So I'm going to ask you to name it. Oh, it's a quadratic, and then we're going to learn another name for it. It's like a first and last name, like a polynomial has a first and last name. Quartic, y equals x to the 4th, and then like y equals x to the 5th. Now, if it's x to the 6th, you just call it 6th degree. If it's x to the 10th, you call it 10th degree. So beyond 5, they don't get a special name. 11th degree, 20th degree. So up through 4, they have a special name. After that, we can just call it 5th degree, 8th degree. Okay, so the part 2 of their name is how many terms there are. A term is separated by addition and subtraction sign. So a monomial has one term. Y equals x to the 7th is considered a monomial. One term. A binomial, y equals x squared plus 8. That has two terms. 1, 2. What does a trinomial have? What does a tricycle have? 3 wheels. A trinomial has 3 terms. Y equals x squared plus 7x plus 1 is a trinomial. Anything after that, this gets a little confusing. They just call it a polynomial, meaning multiple terms, but that doesn't mean that's the definition of a polynomial. Because I said this is still a polynomial function, right? X to the 7th. So there's the category of polynomial functions, and then there's the adjective that something is a polynomial because it has more terms than 3. So, like, what if you had x to to the fourth plus 7x squared plus 3x plus 10. That's just called a polynomial. There's 4 terms or 5 terms. So math is like learning another language, right? We're learning some new vocabulary that we're going to use this year. Okay, so it says let's practice. Use the names to give each of these functions a first and a last name. So the first name is the degree. So on the first example, let's do this one together. That would be what degree? Second degree is quadratic. So this guy's name is a quadratic. And how many terms are there? 3. So I call this guy a quadratic trinomial. That's a mouthful. That's a tongue twister. Quadratic trinomial. Quadratic trinomial. Not really. You do not get it? What? Hurts your brain? Got a new water bottle for Christmas. This one's not spilling. You get a new one? I just realized I should put the cover on. Christmas. Oh, where? Probably Walmart. Is it the same one you have? Oh. But mine doesn't have a straw. Yeah. This one was bigger quantity. Good for restroom? All right, try those 4 examples without me. Okay, so those are your resource pages on polynomial vocabulary. I did have a little bit of factoring review, but before we do 601, I want you to see if you can do the 602 practice, you and a partner. So 602, skip to 602, all the way to page 602, polynomial vocabulary guided practice. What I would do first, look for anything that is not a polynomial, because you don't have to do anything on that problem. Explain why it is not a polynomial. The other ones, you just have to state the degree and the leading coefficient. You don't have to put them in standard form. You just have to state the degree and the leading coefficient. Let me see if I can, let's see, then on the back page, you put them in standard form. Let's see, how many non-polynomials are there? 1, 2, 3, 4, 5. There are 5 failures, 5 no's. See if you can figure out the 5 no's, circle what's wrong with it, or explain in words what's wrong with it. This is page 602. And then go through the rest and say, like, this one is yes. So what is its degree and what is its leading coefficient? Its degree would be 1, right? Because that's to the first power. And its leading coefficient is also a 1, because it's the number that comes in front. So this is the degree, and this is the leading coefficient. There are 5 no's on that front page. If you can't find them, I can help you. 1, 2, 3. Yep, there's 5 no's. All right, you can't find 5. How many 5? There's something wrong with this one. There's something wrong with this one. You find 5? If you're having trouble, letter I was 2 units ago. That was called an exponential function. It has x in the exponent. It has to have a whole number in the exponent, like 1, 2, 3, 4, 5. So there's 5 no's. You can't have a square root. It can't have x in the exponent. X has to be fixed. If you were going to multiply this all out, you'd end up with 2x squared, so it's a 2, right? But you don't have to FOIL it all out to figure it out. All right, so focus. Cross out the ones that don't work. And see if you can figure out the degree and the leading coefficient for the rest. And then if you finish this page, try the 4 on the next. And then you can stop it. All right, identify Do that first. Oh, you've been on pencil the whole time? Oh. Okay. Oh my gosh. Well, you did, but then you gotta be proactive about it. Like, I still don't have a pencil. I still don't have a pencil. I mean, if you look at one of the videos, true. That's a step. Our resource page is going to be filled in. No, it's not. You don't need to comment on it. Question? Oh, you finished? Okay, file the next four on the next page. There's four problems on the back. We're going to state three main coefficients. And the power of the n. So this would be a power of 1. And what number comes in front of it also. So this one has a power of 1, but the number in front of it this time is 2. For this one. Okay. Evan, you hear just one week? Because your last thing is going to be taking a test on machine. So we can figure out how to expedite that. And then that'll be like, yeah. So if you multiply this out, x plus 1 times x plus 1, you're getting x squared. So you're like 2x squared. So 2 is the leading coefficient. Yeah, I like your shit. Parker, how you doing? Here, I'll take one of the units. This is going to be yours. Leading coefficient. You can say 8. Yep. It would be 8x to the 0 power. So, yep. 8 is the leading coefficient. Doing okay? This is yes, because that's a straight line at me. So that is a yes. This one's a no because of that. In the bottom. So that's a no. And which other one did you get? This one's a no because it's absolute value. That's a no because it's a square root. So any of those other functions that you studied are not polynomials in general. Right? The leading coefficient is 1. Because it's the biggest term. The biggest term wins. 2 for the rate, and then 2 is the number that comes. All right, let me put up the answers maybe to the front page so you can kind of skim down and check. Oh, I wrote it on here, but let's see. So this is a yes. The degree is 1. The leading coefficient is 1. Erase it. On B, some of you are having trouble with what degree is. If I actually multiplied this whole thing out, not that you have to, but if you multiply out x plus 1 times x plus 1, you get x squared plus 2x plus 1. That whole thing is being multiplied by 2 at the front and adding 1 at the end. So I'm just going to prove to you what the degree is. 2x squared plus 4x plus 2 plus 1. See how you didn't have to multiply it out? You can see that the degree is 2, and you can see that 2 times the x will give you a 2 in front. So sometimes you don't have to multiply it all out to figure out the degree is 2, the leading coefficient is also 2. We said that C failed because of the square root symbol. This is okay. Degree is 1, and the leading coefficient is 2. Sorry. Degree of 1, leading coefficient of 2. This is x to the first power. That's where the degree is coming from. E fails. It has x in the denominator, and this is x to the negative first power. So it does not have whole exponent. I should say does not have a whole exponent. This is okay. This is like 8x to the 0 power. So my degree is 0. My leading coefficient is 8. Do you have a question on that one? On number E, letter E? and 4x squared. It still fails for it. This is the one that's making it be a problem. G is okay. This is my leading term. So my degree is 3 and my leading coefficient is 1. I just need the biggest power. Why does H fail? It has a fraction in the exponent. So nope. This is not. This has an x in the exponent. That's called an exponential function. You want x as the base, x to the third, x to the eighth. 2 to the x is exponential. And then this one also fails because it's an absolute value function. So absolute value functions are not polynomial functions. So that's a good page to look back on. That'll be like what your quiz looks like on Friday. All right, if you didn't get a chance yet, can you try these last 4 questions? So these are all polynomials. You're going to write them in standard form. And then this time you're naming it. So you might have a quadratic trinomial or a cubic monomial. So you're giving it a first and last name this time. And then that's what part of homework 6.1 is on. The rest of 6.1 we'll learn tomorrow, how to add and subtract polynomials. You might not be able to do all of 6.1 tonight. So take another about 3 minutes. Try that back page, and we're going to do some factoring review, just what you wanted to do on this Monday in January, Tuesday in January. Factoring, factoring, factoring. We did factoring back in October. You guys can remember how to factor? Remember my song? We could do Teach Me How to Factor again. Teach me how to factor. Teach me how to factor. All right, I'm just going to work on putting my answers up so you can check them in a minute. Did you know that if you do something 20 times, you should commit it to memory? So if you did all the practice problems today, these vocabulary words should be committed to memory. Who thinks they went 4 for 4? The names are right. This would not have switched those two because the X should come before the constant. Think you got them all? Oh, well, you didn't quite do what they asked, but the things you said were right. They wanted you to write it like in standard form and then give it a name, like quadratic, binomial. Yeah, so you got them in standard form, so now you're going to name them. Like is it quadratic, linear, cubic, and then how many terms are there? Monomial, binomial, trinomial. So you did the same thing as the front page. Now you want to do what's the name? This is quadratic. There's 2 terms of binomial. So give them each their first and last name. Quadratic binomial. This is quadratic. You guys see the names? You just did the directions in the front page. So like this is a quadratic and it's a binomial. You're giving it a name. First and last name. Every polynomial is first and last name. Adele, you really could be with us on this one. It's nice, isn't it? We'll test the end. It helps your average drastically. 9 days, nail the test. We have to test right in there. All right, you now have a pencil and you know how to do it. Okay, great. So let me put the answers quadratics. All right, so just make sure on the quiz you follow directions. It might not be asking you for the degree. A lot of you didn't even read the directions at the top. You just did the same thing from the front page. They wanted you to write the name. So if you miss the name, you're not going to get points on the quiz. So you want to make sure, maybe you guys are just, you're in Stairsville, but you want to read the directions and practice what the directions are telling you to do. All right, so we should be good on standard form. Homework 6-1, the front page, you could do all 4 of these questions, name it using the number of terms. You're going to have to 5 through 8 because that's on adding, subtracting, multiplying, and that's it. So you could do half of homework 6-1 today, half of it tomorrow. Turn to page 601. Page 601. We've got to dig out your factoring skills from long ago. Dig out those factoring skills. It's also on your final exam. This is good review for final exam. You finished everything except the bonus? Yeah. Great. Thanks. All right. Can someone tell me one of our 4 factoring strategies? Remember any of them? What's the one you should always look for first? Starts with a G. What? Starts with a G. GCF. You should always look for first. What's another strategy we learned for factoring? Never the squares. What's another strategy we learned? Is it trinomial? Right. So a trinomial when A is 1, you just use the diamond. A trinomial when A is bigger than 1, you have to use the bar. So those are the 4 strategies that we need to recall because a polynomial is factorable just like a quadratic. What strategy should I use on number 1? I'm going to identify the strategy and see if you can remember what to do next. This greatest common factor problem. What would I pull out as my greatest common factor? They both have x to the second. So I write my greatest common factor, and then I'm going to go and divide each term up top by the greatest common factor of x squared. What would you have left? X plus 9. Yeah, that wasn't that painful, was it? Do you kind of remember that? What? Yeah, x squared times x gives me back x to the third. X squared times 9 gives me back my 9x squared. What strategy is number 2? It's the difference of squares. X squared is perfect. 36 is perfect. Do you remember how to set up your 2 parentheses? One gets a minus, one gets a plus, and you take basically the square root of each of the terms, right? So x times x and 6 times 6. X plus 6, x minus 6. It doesn't have to be. If you put the minus first, x minus 6, x plus 6 means the same thing. Good question. All right, what can I do on number 3? This is a 2-step problem. What should I do first? GCF first. What can I take out? I'm going to divide both by x. I have to write x, and then I write what I have left. 4x squared minus 49. This can go one more step. 4x squared and 49. Why do those numbers sound so familiar? They're both perfect squares again, right? 4, 49, those are perfect squares. 1, 4, 9, 16, 25, 36, 49. So I take the square root of each of these, and I put one with a plus and one with a minus again. So it would be 2x with a plus 7 and 2x with a minus 7. So this combines the first strategy and the second strategy into a 2-step problem. This is more like what you're going to have to do with polynomials. You're going to have multiple x-intercepts that you find by factoring. All right, number 4. Which method is number 4? That's a trinomial, 3 terms. See, we've used that vocabulary word. A is 1. Remember, ax squared plus bx plus c? So how do I set up my diamond? Do you remember? I'm looking for factors of 25 that add up to negative 10. So what are the factors of 25 that add up to negative 10? What times what is 25? So I want to do negative 5 times negative 5, because that will add up to negative 10. So x minus 5 times x minus 5 is the answer. You might see it on a multiple choice question as x minus 5 squared. That means the same thing. Okay, skip over to number 6. See if you can do number 6 using the diamond method. Actually, 6, 7, and 8. See, I'm skipping number 5 for a moment. Try 6, 7, and 8. 6, 7, and 8 are all the diamond. Do the diamond 3 times to refresh your memory. Just x times x. What? This one? 20 goes on top, and the 9 goes on bottom. Because it's really 20 times 1. So 6, 7, and 8. Now that I've reviewed it with you, if you get one of those on the final exam and you have your open notes, you should be able to recall the diamond method, I hope. To me, that's a big exit question for Algebra 2, is being able to factor a quadratic. So 6, 7, and 8. And then we'll go back. Oh, I actually don't have any on here that are going to need the box, because they're all going to divide out that greatest common factor. Well, that's okay. Factors of 20 that add up to 9. Factors of 2 that add up to 3. Factors of 12 that add up to 8. Remember how hard this was in October? Does it seem any easier now seeing it for the second time around? We really muddled through this unit. I'm hoping that we can remember how to factor the second time around. So this should have been 5 times 4 is 20. So x plus 5, x plus 4 are my factors. Tomorrow, we're going to remember what to do when you set it equal to 0. Remember, the answers would be like negative 5 and negative 4, because it's going to be x-intercepts. But this is just the factors today. And then these would be a 2 and a 1, right? 2 times 1 is 2. X plus 2, x plus 1. Factor of 12 would be what? 6 times 2 is 12. X plus 6, x plus 2. Piece of cake. Okay, 5 and 9. Those are a little tough, but they have greatest common factor. Now pull it out, it's going to be a diamond again. So what can I divide through by in number 5? I can divide everything by 4. So I'll have a 4 on the outside, x squared plus 4x plus 4. Now you can do the diamond method on just this trinomial at your last 2 parentheses. So what are the factors of 4 that add up to 4? It'd be 2 and 2, right? So 2 and 2. X plus 2, x plus 2. So that was actually pretty easy once you divided out before. See if you can figure out on number 9 what you divide out as your greatest common factor, and see if the factor is one more step or if it's prime as the last step. Remember, prime means you can't go any further. So, yep, we're going to divide out a 4x, right? Everything can divide out by a 4x. So see if you can agree with that and determine if it is then prime or if you go one step further. I'm done after this. So I wanted to do a little bit of fact review, and then I've told you all class today, so you can decompress for a few minutes before you move onward. All right, so let's see. I'm going to have x squared minus 2x minus 3 cannot go any further. So Is that what you're asking? See how I took 4x out? So then I would have x squared minus 2x minus 3. 4x decreased each of the exponents by 1. So I have a negative 3, negative 2. What are the factors of negative 3 that add up to negative 2? Negative 3 and 1. So I can factor it one step further. It would be x minus 3 and x plus 1. So if this seemed really hard for you, we need to do some good factoring review. If it seemed like that refreshed your memory, then you're going to be pretty good this unit on factoring, because that's about the level of factoring that you're going to be seeing when we work on this. All right.